I'm going to go to the website. That's github.com/JustinThompson593/algebra2. And when you see this, it will probably not be black because I am signed in my GitHub account right now, and I have chosen to have a black background for my app. And so it'll look probably just like this. If you're on an actual browser on a computer, if you're on your cell phone, it's going to look a little bit different. This is what you see when you go to the main page. Now, like I was saying, if you're on a mobile, you will probably not see anything past these first folders where it says homework, lectures, and quizzes. And that can be really confusing, like if that's all you're seeing and stuff like that. But every page that we have here on this website, if you scroll down, you see the README, readme.md. And that's basically, I'm writing those so that is like the main page. As though there's nothing else on the page, this is where all the information is stored.
Okay.
And here you could see that I have the hyperlinks to the different directories. You could also get to the directories by clicking the actual folders up there where it says homework, lecture, and quizzes. But I also have them here here on the README as though it's a regular website and there's links. So just right here, it says class materials can be found in the directories, blah, 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 blah. These can be found in the lectures directory. So I'm going to click on the lectures directory, and that will take us to the lectures directory. And we can see again, we have the README right here with all the information. There's a link to the playlist. And if you click on the playlist, it takes you to the full-blown playlist of Algebra 2 lectures. Lectures 1 through, now we're down to 23.
Oh.
Going back, we're on the lectures page, and I have a short description of each lecture, right? So this is lecture 1, functions, and then a little blurb on everything we did in those lectures. At the top of everything, you'll see a blue link to video. And we click on that video, it takes us right to the YouTube. Hey, look how short my hair was. Nice.
Whoa.
So it takes us right to the video in question. And so we have all of those going all the way down to what we did last time, lecture 23. I click on the video link, it takes us right to the video. Okay, so I'm going to go back to the main page. Here to Algebra 2, and I'm at the README at Algebra 2. It says quizzes, their solutions and links to the solutions are found in the quizzes directory. So I'm going to click there on the blue hyperlink for quizzes. And you see a bunch of stuff, and you're like, what is all this stuff? And what is latex? And what is all that blah, 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 blah. Well, remember, this is how it's stored. The information is all right here in the README.
Okay.
And in fact, all of this information here in the README, all those links that you see are straight up links to this information up here. Now,
which are all of the solutions?
Those are the solutions, yes. And then there aren't actual solutions. Well, we'll go through that in just a second. One thing I do want to bring your attention to is this folder right here that says latex. It's actually pronounced LaTeX or LaTeX. If you click on that, which you do not need to do this. I just want to show you what this is. Quiz 0. Now, actually, let's do quiz2.tex. If I click on that, this is how I wrote up your quiz 2. This is the code that you write in. It's a programming language called LaTeX.
Oh my.
It looks like latex. And this is what mathematicians and scientists, some scientists use when they publish papers, or if you're a professor, if you write up your quizzes and exams and stuff, this is what you use. And so I just have this here really to keep everything in one place, but also just in case at some point in the future, you have this information. If you should ever want to write something in LaTeX, now you have some information. Now you have like some templates that you could use.
Hmm.
So like I said, here at the top, you could navigate directly to these different things, quiz 0.1, quiz 0.1 solutions, etc. Or we could just use it right here. Reading the README, we see, okay, quiz 0, link to quiz 0. It takes you directly to quiz 0. And this was
Got you. Okay.
now when there are, for quiz 0, I did not do solutions. As you can see, there are no solutions up here. I did them all on a video. And so right here under the link to quiz 0, I posted a link to the video solutions right here. Now that's what my beard usually looks like. So, so going back, all right, there's that. Ditto with quiz 0.1. 0.1, I also wrote up solutions there. So here's the video solutions right there. Quiz 1 was all odds. The answers are in the back of the book, and we went over these. Okay, and so link to quiz 2. I did not put a link. I thought I did put a link. So up here, you could see that I did a quiz 0.1 solutions. I wrote them out and they're right here. And so there's that. Going back, so that was just up here in the actual folder. I might change that first later, but anyway, finally quiz 2, the link to quiz 2 itself and the link to the solutions. All right there. Okay, so going back, one more thing to talk about. Oh, and also if I do any more videos of solutions for quiz solutions, I'm going to put them all in the same playlist, and that link to the playlist is right here where it says quiz solutions playlist. Click on that, takes you to YouTube, and those are the solutions. Okay, going all the way back to the main page, the last thing to look at is homework assignments and solutions are posted in the homework directory. So I'm going to click on the homework directory. Homework directory. Again, here I have the written assignment and solutions to that written assignment. Everything else is straight out of the book, and it has, I go to painstaking detail, or I'm very certain to copy down exactly what I put on the board right here. And so if for any reason you don't have, or you're wondering what it was, this is what I put on. I've noticed that you and I are off by one number of homework, meaning like you've been writing homework 15, but I've been calling it homework 14. And I think, yeah, buddy. And I think the reason for that is I assigned one evening you to do some like makeup or something like that. And I said, that'll be the homework, but I didn't call it the homework.
Got you.
So we're off by one. So if that's a little confusing, if you go, wait a minute, you're missing one. I just did homework 17 and this is homework 16. That's why we're off.
Okay.
So,
I think I did end up correcting the numbers.
Oh, you did? Okay.
I think so. I think I did.
Cool. Yeah, I'll take that whenever you're ready to give it to me. And so, okay, just one last thing I want to talk about on the website is eventually we're going to have an exam. And as you could guess, I'm going to make a brand new directory for that. And it's going to look a lot like the quizzes directory or page. I guess we'd call it a page. Instead of quizzes, it'll be exams. And I'm going to do the same thing. If I do a video solutions, there'll be a link to it there. If I do written solutions, they'll show up here on the README. I did not link to these solutions on the README, but anyway, okay. So does that make sense? Is everything good here with the website? Any questions?
I don't think I have any questions.
Okay, cool. So that's the website. Since we're online, might as well show you a couple more sites, and especially since we're going to take our time now while you recuperate, and we're not trying to push too far ahead. Do you know about Wolfram Alpha?
No.
Holy moly. I've basically, okay, here we go. Wolfram Alpha That's, as you can see up there, wolframalpha.com. I'm going to go there. Pretty much anything you want to know shows up here. So let's, for instance, let's say we had a polynomial x squared. How about minus 3x minus 2? How about equals 0? Let's see what happens. Let's just plug that in and see what it does. Well, it'll plot it for you, which is nice. Shows you where the roots are. Shows you alternate forms for how we could write this thing. There's these 3 alternate forms. Gives you solutions right here. These are the solutions to that polynomial. Why is that not minus? Oh, here, let's change that to a plus 2 and a plus 3. Aha. One of the alternate forms is it's factored. So if there's something that, if you just type in something that is factorable, it'll do it for you. And if you were to just type in the polynomial itself without the 0, it will.
Is it free?
For you. It is free. It is absolutely free. Now, there are certain, what do you call it? Little perks that they have, or that you will not have access to. Like, for instance, over here you see step-by-step solution, and you're like, ooh, yeah, let me see that step-by-step solution. Oh, and it actually gives it to you in this case. But you see right here, it says go pro now. Oh yeah, to unlock the full solution. They'll give you a little teaser about this stuff. But you could, if you want, you could subscribe and buy a membership or whatever it's called to get Wolfram Alpha Pro, and you have access to a lot of crazy stuff. So this is a computational search engine. Also, it does cool stuff like this. Like when I have a recipe that calls for 2 1/3 tablespoons, or how about teaspoons? Yeah, how about tablespoons? Tablespoons. I just type that in, and it gives me a bunch of conversions. Hey, it's 7 teaspoons.
Whoa, that's awesome.
How cool is that, right? Also gives it to you in fluid ounces, milliliters. Does comparisons as volume, which is really cool if you want to do something like this. How about volume of the universe? Let's see what the volume of the universe is. It tells.
Wait, you can measure the volume of the universe?
Well, it's an estimate. It's an estimate, and there are various ways of doing it. We're assuming, I think this assumes that it's a sphere, and it is based off of the distance to the cosmic microwave background. You could look that up if you were so inclined. But yeah, so there, yeah, it's an estimate, and there's a radius of the sphere of that. I mean, it has pretty much anything you want. Here's another. This is one I've looked up a few times. Volume of a human, or of a human. What is the volume of a human? Your average human body. It's 66.4 liters. Hey, that's actually, it comes in handy with certain things. Anything you want to know in chemistry? How about volume of 2 liters of gas at, or no, 2 liters is.
I really wish I had known about this when I took chemistry.
Yeah. And so, like, for instance, if you're trying to convert, let's say 33.3 meters per second to miles, how about mph, miles per hour? You just type that in, and it understands that what you want to do is convert 33.3 meters per second to miles per hour. And so this is a huge help.
Wow.
Yeah. And so, yes, this is your new best friend for pretty much anything. Now, of course, I'm just going to say this will not actually help you to get concepts and stuff like that. This is, I would highly recommend using to check your work, right? Like that. But you still need to go through like for instance, if you're taking a chemistry class and the question is convert 33.3 meters a second to miles per hour, if you just write down 74.5 miles per hour, you won't be right because you won't have shown your work, right? But this is a great way to check your work and etc. So that's Wolfram Alpha, and pretty much anything you want. Let's do one more. This is pretty cool. I want to look up 1 terabyte.
1 what?
Terabyte. So like you have a gigabyte, a terabyte is better than that. Here's this comparisons. And this is the great thing. They give you, anytime you give a quantity, it gives you comparisons. So it's like, so first off, it's 931 gigabytes, right? So you imagine, you know what a gigabyte is, 931 of those guys. But how much is that? Well, it gives you, I love this, it gives you a comparison. It's about 5% of the content of the Library of Congress. Stuff like that. It's just really cool. Time to download at cable modem speed. 3,509 minutes or 2.4 days. Time to transfer. Yeah, it's really cool stuff. So that's Wolfram Alpha. There's one other site you should know about, and it's Desmos. Desmos.
Oh, I love Desmos.
Okay, so you know about it. In particular, and you can see it's already up here, calculator. That's what I use, right? So you go to Desmos Calculator, and you could graph things like y equals x squared, and it graphs it. And then we say, how about y equals, how about 2x plus 1 right there? And we can see, oh, there's 2 intersections. And so this intersects over here somewhere, and I could zoom in right there. Intersects right there. Intersects right there. I could zoom in on that intersection. Really cool stuff. What's also nice is you could do things like this. Y is greater than that, and it shows you the region where it's greater than. And look at that. Remember when we were doing this? Like it does it the way that we've been doing it. It uses a dotted line because it's strictly greater than. And it's Y is everything above that line. And so that should be pretty familiar. I wonder if you could do equals. Yep. And then I typed in there, I wrote Y is greater than, or, and now I'm just going to hit equals, and it automatically knows what you're doing. Square root of X. Okay. And so on and so forth. So, okay. You know about Desmos, you know about Wolfram Alpha, which is now going to be your best friend. And we have our website here. And I think that's pretty much all I wanted to do online today. What we're going to do right now, since we're taking it easy today, I would like to actually, let's go over the redo questions that I wanted you to redo. I can't really get on my phone right now. Could you tell me which ones we were supposed to redo?
You texted them to me? Okay, yeah. Number 25, number 27 and 29 and 31.
Okay, 25 was from this last one, correct? Or
And then number 27, 29, and 31 from the previous homework?
Okay, from 6-6, 27, 29, and 31. Okay, so let's do number 27 from 6-6. Okay, so this is 6-6, number 27. All right, we have 2x plus 3 over x minus 1 equals 10 over x squared minus 1 and plus 2x minus 3 all over, it should be x plus 1. Yes, x plus 1. Okay,
I thought I
now
already redid this one. Unless I did it again.
don't think I saw it. You did redo this one. Well, you did this one, but it was, well, at least if you redid it, I didn't see it.
Oh, you're kidding me?
Yeah. I don't think you sent
What?
those to me. You did not send those to me. So let's just okay, then since you redid this, I'm going to go through it really quick and you tell me if you did anything different.
Okay.
Okay. So
yeah, I redid both of these.
You did. Okay.
I didn't send them to you.
Yeah, just go ahead and send them to me. And I'm going to go ahead and just knock this out. You tell me if this is what you did. So I noticed right away that one of these denominators factors. And in fact, when it factors, it's going to factor into the other two denominators, x plus 1, x minus 1, like this. So I rewrite this guy. And that helps me out. And so I say, okay, if I multiply everything through by x plus 1, x minus 1, which is what you did the first time. And so we go x plus 1, x minus 1. X plus 1, x minus 1. On both sides. That kills the denominators. This guy kills that guy. And all we're left with is x plus 1 times. And this was the key here, right? To treat that like that. When you redid it, did you do this?
Yep.
Okay, good. So these guys jump over and kill these guys. All that's left is a 10. This guy is a 2x minus 3 times, well, the x plus 1s cancel, and I'm left with just an x minus 1. And so now I have to FOIL these guys out. I do that. I get 2x squared plus 3x plus 2x gives me a total of plus 5x's. Plus 3, first outer inner last is all I'm doing. The 10 stays put. First outer inner last gives me a 2x squared. Outer is minus 2, inner is minus 3 for a total of minus 5x's. The last gives me a positive, yes, because a negative times a negative is a positive 3. So now I'm going to go ahead and, oh, what's really cool is this guy cancels that guy. The minus 5x can come over here to become a positive 10x. So those guys are gone. How about the 3 cancels this 3 right here, and they are gone. I get 10x equals 10, divide both sides by 10. And I get x equals 1. Then what do we have to do?
Do the little thingy with the X and the weird E thing and the brackets, I think. Oh. Do you have to do that if you said you don't want me to answer with X equals 1 or whatever anymore? You want me to do the X with the weird E thing?
If it's one element, this is perfectly fine.
Oh, okay. I did both of them.
Be fine in this case. Is X, can X equal 1 in our original equation?
No.
No. In this case, we plug in an x equals 1 and we get division by 0 right there, division by 0 right here. And so x equals 1 is not a solution. Got to be careful for that, right? And this is the first time that we really encountered.
I forgot that on my redo.
What's that?
I forgot that when I
redid it. Yeah. And so this is a new thing. We haven't had to do this before. Now we must go back and check our work every time, but we don't really need to plug it in and get everything out. We're really just looking for, in this case, division by 0. If we have division by 0, we're screwed, so we can't do it. And so that's really all we're checking for with these types of problems. Whenever we have variables in the denominator, we have to go back and see. And so in this case, there is no solution. And we could say, the solution set is empty. We could do it like that. We could do it like this. That means the same thing, that 0 with a line through it means the empty set. Or we could just say no solution.
Okay.
However you want to do that, I'm not a stickler about that. If you have multiple solutions, let's say at the very end, we got down to here and we got x squared. How about plus 3x plus 2 equals 0? And so you go through and factor that guy out and find, okay, how about x plus 1, x plus 2? And then you had two solutions. I realized I have one with a 1 in there. Let's pretend that these weren't 1s, if they were like 5s or something, and 5 and a 25 and a 5. Then in this case, you would say, I have two solutions. X is either equal to -1 or X is equal to -2. But I don't want it written like that. I would like it whenever you have more than one actual solution, then we write it in a solution set. Say X is in this set. If X is in this set, then it will make that original equation true. Okay, so that was one of them I wanted you to redo. And the reason I wanted it redone, and because I did want to talk about this, is that when you originally did this, oh man, I erased everything I wanted to talk about, man. All right, well, we had this right here. When you originally did this, what you had done, right, you had something like this, x minus 1, and then you had 2x plus 3, and you said, okay, we have an x plus 1, x minus 1. And you said correctly, like, yes, that cancels that. But then you treated this as something like this. You went forward and said, okay, there's the 2x plus 3. And then you distributed this guy in and got 2x squared plus 2 plus 3. And it's like, no. The point, and this is why I'm talking about this right now, is that anytime you have something that looks like this, every single numerator has to be considered as one thing. And in your mind, whenever you look at these, your mind should draw these in for you, right? You should think like whatever's in that numerator right there is one big fat thing. And so just to really drive home the point, if I had something like this, x squared plus 2x plus 1 over x equals, how about 3x over x minus 1? I'd say, okay, in order to kill the denominators, I need to multiply by an x and an x minus 1. And so I go x times x minus 1 on both sides, x times x minus 1 on both sides. And over here, the x's cancel. And now this entire thing that's up there has to be considered as one thing. And so it would have to be whatever we get when we do this, which we know because we've done this before. You would have to distribute this x into each one of these guys, and then distribute this -1 into each one of these guys and add them up. If you remember, right, it's really nice to put your x cubeds here, your 2x squareds here, your plus x, and then line everything up, right? When the -1 comes over, we put that right there. The -1 comes over when we put that guy right there. The -1 comes over and we put that guy right there. That way they're in these nice columns and everybody here is an x cubed. Everybody here is an x squared. Everybody here is an x to the first and then x to the 0. Okay. Not going to beat that point anymore. Dead horse. We're done. And you had just come back from Christmas break and had the coronavirus, right? Like, don't take any of this as criticism. Like, if you didn't make mistakes like this, I would be a little worried. It'd be like, like studying during Christmas break, you need to chill out. Like, but it's good though. Like, believe it or not, making mistakes is one of the best things you can do in math, because then once you've done it and you've seen, oh, that was wrong, now you know that it's wrong, right? And you'll be better next time. Okay, so there was 27. I also asked you to redo 29. Oh yeah, oh boy, 29, this guy. So x cubed plus 8 over x squared minus 4. This guy was x squared minus 2x plus 4 all over x minus 2. Now, there's a few different ways we can do this one. One way is to say, wait a second, that's a sum of 2 cubes, right? You should recognize this. because we've done these about 100 times now, is that we could recognize that this is this guy right there. Therefore, how does a cube break up?
That
What's the acronym?
soap,
So,
right?
okay, yes. So, okay, so that's nice. Now, this part, it's one of these and one of these in the first, right? So 1x
Yeah.
2.
So it's going to be plus 2.
Yes, it's going to be plus.
And
Now, what are these? There are 3 terms here. And what are
yeah, x squared, 2x,
2x
and then 4.
and 4, right? So in other words, it's the things to the first power, and then there's 3 things to the second power, right? It's the thing squared, it's that thing times that thing, and then it's that last one squared. So then the opposite sign would be a minus. Always positive is always positive. So right away, if we were so inclined, we could say, well, that top thing breaks down in the following way. You could say that that very top thing is this: x plus 2, x squared minus 2x plus 4 all over, and we'll go ahead and finish that up in a second. I'm just going to copy this down without using my brain. Okay, we have that. Now this breaks up. What does that factor into?
Yeah, that is x plus 2 and x minus 2.
Yeah. I'm just going to double check that real quick. Outer, inner, last. First gives me x squared. Check. Outer, inner cancel because we have 2 x's, one's a minus, one's a 1. Negative and a positive make a negative. 2 and 2 are 4. Yep, that checks out. So now I can see, aha, this guy cancels out there, cancels out there. And now I have an identity, right? It will always be the case that if I take a number, square it, multiply it by 2, subtract that guy away, then I add 4. Take that original number, subtract off 2. Yeah, you see what I'm doing. I'm just plugging this stuff in. That you'll get the same thing in both cases. That's always going to work. And so we'd be tempted to say, I mean, and if you really wanted to, you could say, well, now multiply both sides by x minus 2. Okay, so you do that on both sides. That has the effect of canceling those guys. Then you could say, oh, well, let's, oh, this cancels that. Yep. This cancels that. Yep. This cancels that. Yep. And so what we're left with is 0 equals 0. When does 0 equal 0? Until forever and always will always be true. So it makes me think that I could plug in any number for this, for x, and the left-hand side of the equation will always be equal to the right-hand side of the equation. But what's the problem? Can I plug in any number for x?
No. You can't plug in -2 for x or 2.
There you go. There you go. Because of these guys right here. If I plug in 2, I would have a 2 minus 2 is a 0. Can't happen. Over here, we could think about this a couple ways. That if I plug in a 2, square it, I get 4 minus 4, 0. -2 also has that property because -2 squared minus 4 is 4 minus 4 is 0. Can't do it. Or we could think about it. It's usually easier to say, well, if I factored this guy out, x plus 2, x minus 2, because that's already written somewhere on your page. And you know, you can just look at it. Okay, if x is equal to 2, I'm dead. So x cannot equal to 2. If x is equal to -2, it cannot be equal to -2. So how do I write this in interval notation? I could plug in every real number except for those. How do I do that in interval notation?
Okay. You do the soft bracket.
Yep.
And then the negative infinity.
Yep. All the way up to what?
-2.
Yep.
Soft bracket.
Yep.
Union.
Mm-hmm.
Soft bracket. -2, 2.
-2 to 2. Yep.
Soft bracket. Union. And then soft bracket to infinity.
There you
Soft
go.
bracket.
So that is the solution set to that equation right there. That is it. Now, I said that's one way of doing it. If you recognize that that guy broke down into that guy. If you didn't, and so I'm going to go along with what you did, which I believe was something like this. You have x cubed plus 8. You go ahead and factor this guy as x minus 2x plus 2. And then we have whatever's up here like this. And we have this right here. And we say, aha, in order to kill every denominator, because that's what I really drilled into your head is the first thing we want to do when we see something like this. So let's do it the way that I drilled it into your head. We're going to kill every denominator by multiplying both sides by that guy. Yeah, that'll do it. And that. So x plus 2x minus 2. Okay. X plus 2x minus 2 right there. So those guys kill those guys. All I'm left with is an x cubed plus 8. This guy kills this guy, and I'm left with an x squared minus 2x plus 4, all in parentheses, which is super important. And then an x plus 2, like that. Now, at this point, you might notice, and if you don't, it's okay, because we'll see, it's not fine. You might notice that, wait a second, that's like the identity for that thing. Now, we usually write it in this order. We usually write it with the x plus 2 and then this guy. And you might go, wait a second, that is what that is. I recognize that like sum of 2 cubes breaks into the first thing, the second thing with the plus, and then the squared, the 2x, and the 4. But if you didn't notice that, I would think, well, why don't I multiply this all out, and then I'm just going to collect all the terms on one side, because that's what we do with polynomials. We set them equal to 0. Can't set it equal to 0 when they're multiplied like this. So, well, I could, but it's nice if I had every single term. So what I'm going to do is go ahead and multiply this guy out. I'm going to distribute the x in first. X times x squared gives me x cubed. The x times the minus 2x gives me minus 2x squared. The x times the 4 gives me a plus 4x. Okay, so the distributing the x part is done. Now I'm going to distribute the positive 2. The positive 2 jumps in like this. Positive 2 times x squared is positive 2x squared. Positive 2 times negative 2x is negative 4x. Positive 2 times positive 4 is positive 8. And then I add all these guys together. And I did this way like a minute ago because these columns help me out. I'm going to say x cubed plus nothing is just x cubed. The plus and the minus is gone. The plus and the minus is gone, and I'm left with a plus 8. Okay. So all of this then works out to x cubed plus 8. So I say, okay, that equals x cubed plus 8. Oh, yeah, that's why this breaks down into that in the first place, is because that's how it works, right? That's why we have a formula for it, because that always works that way. And so, okay, I forgot that there was an identity I could use at the beginning, but whatever. I went through and did step by step and ended up with something that equals itself. Obviously, if I wanted to go ahead, I could say, well, that means 0 equals 0. Cancel the x cubed on both sides, cancel the 8 on both sides, and you get 0 equals 0. Should always be true, except for those two places that we talked about earlier. and you would end up at the same answer. Okay, so are we good with number 29?
Yes.
Okay, then I think I said, was it 30?
You said 32, and then you just wanted me to write it in interval notation. You didn't want me to redo it or anything.
That's right. I said we don't need to redo it. And that one is indeed another identity. 32 was this x minus 3. Okay. Couple ways we could look at that. Kill the denominator, or just like before, we could either factor at the top and do some canceling, or we could say kill denominators. And if I kill denominators, well, the only denominator in the picture is that guy. And so I multiply by that guy. Those guys are dead, and I get x minus 3 squared equals x minus 3 times x minus 3 is x minus 3 squared. Means the same thing as that. And so you think, okay, we're good. So all real numbers work except for what?
3.
Just 3. And so how do I write that in interval notation?
You have a soft bracket.
Mm-hmm.
Negative infinity to 3.
Mm-hmm.
And then the union sign. Or another soft bracket, I guess. And then a soft bracket, 3, and then the infinity.
So infinity, go, right? And that's our idea, that we're taking the entire real number line from minus infinity up to infinity. We're pulling out the number 3. We're not including him. And so what's left over are these two intervals right there, everything down there, everything up there. And yeah, looking at that original equation, I could see, yes, that will work no matter what. No matter what I plug in, as long as it's not a 3, that should work, because that means the same thing as that, and et cetera, et cetera. Okay, good, good. And yeah, I remember all I wanted you to do was just to write that right there. That was the idea. Okay. Okay, so that concludes 6-6. Then what was it? It was 25 from the last one?
Hold on, let me
Wait.
check. I think it was.
Oh yeah. It was 25 from
6-7.
So 6-7, number 25. Okay, here we go. A rational numeral. Oh boy. A rational number. I'm gonna write it as number, a rational numeral. Who says that? Nobody says that. All right. In a rational number, the denominator is 8 more than numerator.
Oh yeah, this one.
Yeah, this is tough. This is why I assigned it. This is a good one. If 5 is subtracted, okay, so if 5 is subtracted from, I have to be really careful here. If 5 is subtracted from both numerator and denominator, from both.
Oh, actually, I think I did the wrong one.
Yeah.
Your video went out.
Okay. You think you did the wrong one?
Yeah, there was one. 25. Yeah, I accidentally did 24 on that one, not 25.
Oh, I see. Yeah, that is what it looks like you did. If 2 is at, yes, because I was looking at it, I was like, where'd you get 3 and 2?
Yeah, that was
2. There's a 5, but if you subtracted the wait.
Yeah, I think my eyes just like I don't know what happened there. I think sometimes I see a number and I don't. Then I look up at the next problem and I don't know.
Yeah, it's the story of my life. I know. That's so. Let's do this one. And in fact, you're gonna do it here. If 5 is subtracted from both the numerator and the denominator, the result you get is 1/2. Okay. All right. What do you want to do?
Oh boy.
So let's start. Let's break it down. A rational number. What does every rational number look like? Something divided by something else. Period. That is that simple, right? That is what that means. I'm just taking the definition of what a rational number is. It's understood that those are both integers, right? That might be a -3 and a 7, or like a 13 and a 24. Okay, but those are two numbers, one over the other. So it says in a rational number, the denominator is 8 more than the numerator.
Do you need anything?
So how am I going to write that?
Eight is on the bottom, obviously. No, wait, no. The denominator is 8 more than the numerator. So I guess x is the numerator,
Yeah.
and then x plus 8 is on the bottom.
There you go. Now I'm going to stop and check you here. Because this is what if I were doing this is what I would say, wait, rational number is some number over another. Okay. Now the denominator is 8 more than the numerator. That's what I just wrote. Let's just see. There's the denominator. Yes. Is that thing 8 more than the numerator?
Yes.
Yeah, it is. Okay. So this is the number that we're looking for. Okay. So now it says if 5 is subtracted from both the numerator and the denominator, the result is 1/2. So how do I write that?
Would you just subtract 5 or add a minus? Hold up. Sorry. Wouldn't you just write a -5 on both sides and then equal that to 1/2?
You mean both sides of this?
Yeah.
Yeah, on the top and bottom. Yes, you're absolutely right. So because like that, we don't have a name for that operation. They're describing something very weird. And that's what I mean. Like we have to be, when I said a minute ago, we have to be really careful when we write this down because that's not normal. Like if they say, if you subtract 5, well then yeah, that would be this number -5. Here they say, if 5 is subtracted from both the numerator and denominator. Okay, so that's what they're saying. If you take your numerator and subtract 5, and then you take your denominator and subtract 5, then the result is 1/2. Okay, so now you tell me what to do. What am I doing?
Yeah. So would you go ahead and simplify on the bottom real quick?
Yep, which is what?
3.
Yeah, so the bottom should
X plus 3.
Yes, just x plus 3. Okay, now what do you want to do?
Multiply both sides by x plus 3 and also 2.
Yeah, good. Okay, so 2 and x plus 3 over here. 2 and x plus 3 over here. Okay, let's do this side first. What's left on the right-hand side?
X plus 3.
Just x plus 3. Yep. Now, what about the left-hand side?
So you have a 2 times x minus 5, I think.
Yeah, but not 2 times x.
Right.
And minus 5, right?
It's the
So 2 times x minus 5. Okay, now what do you want to do?
Could you, so what is it called? Multiply the bracket thing in by 2.
And what does that give me?
2x minus 10
minus 10
equals x plus 3.
plus 3. Now, what do you want to do?
Well, solve for x. So then I
Alright.
guess you could add 10 to both sides and then subtract x.
Okay, so you said first add 10 to both sides. If I do that, I'm going to go ahead and erase right here. If we add 10 to both sides, we are left with 2x by itself equal x, then what?
Plus 13.
Plus 13. Now,
And then
do what?
subtract x from both sides.
Leaving me what?
Oh, wait.
You're right.
What?
You're right. We want to
Yeah.
subtract x from both sides, but what do we get when we do that?
X equals 13.
Equals 13. So then what's my answer? What is the irrational number that they're looking for?
They're looking for the original number, right? So you have 13 over 13 plus 8, which is 21, is it?
So that sounds right. Yeah, 21. There you go. So that is the irrational number that they're looking for right there. So yeah, I was wondering where the 2 and the 3 came from, and I should have just looked at the nearby questions and been like, oh, you just did that one. But yeah, so yeah, this is tricky stuff, especially when they tell you when something is subtracted from both the numerator. Like, what is that? That there is no such operation like that, right? So you have to be really careful with this, but this is, yeah, so this is it. That was the answer right there. And if we wanted to, we could check, yep, that is a rational number. Yep. Okay. If you subtract 5, and okay, it's a rational number. Check. It's 8 more than the denominator. 21 is 8 more than 13. And if you subtract 5 from both the numerator and the denominator, well, let's see what happens. Was 13 minus 5?
8, isn't it? No, wait.
Is it not? 8,
Yeah.
9, 10, 11, 12, 13. Yeah. Okay.
Yeah.
21 minus 5.
16.
16. Is 8 over 16 the same thing as 1 over 2?
Yes.
Yeah, I think so, because that's the same thing as 8. 2 times 8, the 8's cancel, and I get 1/2. So yes, we have the right guy right there. Okay.